class before us was so easy. What did Hitler
This is one
do before he died?
Yeah.
Wow, that was yeah.
All right, we are going to start our next unit today. Maybe that's not the correct wording, because we're still in Unit 1. Unit 1 was very long, so I decided to break it up, not necessarily in half, because if you noticed, the notes for this part are a lot thinner, okay, than the last one. So we had 7 sections in our last unit. This time we're only going to have 4, okay, so it's a little shorter. But since this is still Unit 1, you're going to see a lot of the same concepts that we've been talking about, okay, the remainder of this unit. So we're going to look at absolute values in this section. We'll eventually get to talking about more about graphs, okay, different properties or things we can list, okay, characteristics. So we're still in Unit 1. Since it's shorter, because I had a few people ask me yesterday if we're going to have any more grades by the end of the quarter. And the answer is yes. I just don't know how many, okay? So I am 99% sure that we're going to be able to get in another quiz, okay, before the end of the quarter, but the test is still a question mark, okay? So depending on how quickly, I don't want to rush it, but depending on how quickly we can get through some of this, we might be able to fit the test in. I'm not sure, okay, but 99% sure about the quiz, all right? So for this first section, we're going to revisit absolute values, but also piecewise functions. So we're going to kind of merge the two together. If you were to take a look at this equation on page 87, just for practice, can we identify some transformations, some shifts or movements? Go ahead, Emma. Down 3. Like it? Yeah? Left 4. Yeah. Vertical stretch by 2. Oh, perfect. Okay, so at first glance, I like how we can label those. Can we think about, if we were to apply those transformations, where the vertex of the V shape would be located? Can you give me the ordered pair? If it's normally at the origin and we do those changes, where is it now? Yeah.
-4, -3.
I like it. Okay, left 4, down 3. So from the origin, left 4, down 3 would put you right here. So we're going to test to see if that's actually right. I know we can look at that and identify the transformations. Let's see if that's the correct vertex. So we're actually going to graph the absolute value on your calculator. Okay, I think this is something new that we haven't done yet, at least this year. Maybe you have in the past. So on your calculator, turn it on. And if we're going to graph something, you have to go to y equals. If there's anything in there, go ahead and clear it out. Are we familiar with where to find the absolute value bars on our calculator? Do you know what buttons to press? No? That's okay. Second? And then what?
Second and Y.
That's okay. That brings up our stat plot. We've done that previously. No? Try this. Okay, hit the math button. It's right underneath alpha. And I want you to scroll over to number, N-U-M for short. So here's your arrow key. And it's the first one, ABS, okay, for absolute value. That ABS does not stand for abs. Okay, your calculator is not ripped. It's mentally ripped, okay, but not physically. So if you hit enter, it should bring up the bars. And inside the bars, we'll type in 2x plus 4. Yeah. Not second math, just hit math. Just math. Over to number. Got it? Okay. Now, our equation still has a -3, so you have to arrow over to get out of the bars, and then you can hit -3. Before we hit graph, we need to hit the window button to make sure we can actually see what we want to see. And we're going to go ahead and use the window from the graph on our paper. So we go -8 to 4 on the x-axis, counting by ones, and then -5 to 7 on the y-axis, counting by ones. So with the equation in and the window set, go ahead and hit graph. So it's a V shape, just like we said it should be. Were we right with our vertex location? Unfortunately not. Where is the vertex? -2, -3. So why do you think our vertex was off? I mean, we identified the transformations, I thought. Why is it a -2 and not a -4? Can we take a guess? I mean, I see a +4 in there, so I think it would go left 4. But why did it only go left 2? You have an idea, Seth? It's because of the 2 also on the inside. Right. Remember how when we first started doing transformations, if we had like -x -4, didn't that negative kind of change the way things were moved? Right? The 2 is kind of doing the same thing. So notice how if there's a negative in front of the x or even a number in front of the x, that's also affecting the left and the right motion. So how we should actually think about this is if we were to factor out the 2, okay, like get rid of it, GCF, pull it out, we would have an x +2 on the inside of the bars. And isn't that a little bit easier for us to see that it's actually going left 2? Right? Instead of the left 4 that we thought it was. So the inside is always tricky. Not only does it do the opposite of what we would think it would do, but if there's something in front of the x, that's also affecting the left or the right motion. Okay, a little tricky there. Anyway, now that we have the correct graph, let's go ahead and plot some more points on here. So some other ordered pairs that I see, a y-intercept of 1. Let's see, 1, 2, 3, 4. It looks like we have -5, 3 as another ordered pair. Okay, if we plot some points, we'll go ahead and draw our V shape. So what we're going to try to do in this section is go from a V-shaped graph and write it as a piecewise function. So if you think about the V shape, you essentially have 2 lines on either side. So we're going to figure out the equations of those lines. Okay, we have 2 lines, so we're going to have 2 pieces. What information do you think would be useful to determine to write the equation of a line? Good, Lucas? Slope? Okay, so let's maybe do this first line. Can we find the slope of that first line? Pick 2 good points, do rise over run. What does it kind of look like it should be? Go ahead, Emma. -2. Okay, so slope, always a good graphical characteristic to find. What else might be useful to write our equation? We're essentially halfway there. We have mx and now we need b, which would be the y-intercept. So the first line, unfortunately, does not cross the y-axis like we would want it to, but if you were to extend it, can we think about where it would cross? Is it -6? No. -7. -7. Okay. So you'd have to follow the slope though. So down 2 over 1, you'd land here at -5. If you go down 2 more, you'll land at -7. Okay, so -7. Perfect. Let's do the same thing for the other line. So slope, pick 2 good points. Looks like a slope of 2. And then this one clearly has a y-intercept of 1. Okay, so there's our piecewise function. But we still have to do the domain section. Okay, so piecewise functions have the equations and the domain. So we got to do both. So the first line, notice how it stops at the x value of -2, and it's everything to the left of that spot. So we'll say x is less than -2. Can we include -2? Yeah, because there's a closed circle. It's actually our vertex, right? So we'll go ahead and put a bar. The other line starts at -2, and it's everything to the right of it. So x is greater than -2. Can we include that -2? Yeah, Yeah, because they're still the closed circle, right? It's the same closed circle. So you could have a bar on both. That's okay. So there's our piecewise function. Now notice how we created this piecewise function based off of the graph, right? That was essential for us. What we're going to try to do in this section is create the same piecewise function, but without the graph. Okay, we're just going to do it by looking at the equation. Okay, so this is where it's going to get a little bit higher ordered here, higher ordered thinking. In order to do that, I gave you some guidelines that we're going to kind of be practicing throughout this section. Now, I give you the guidelines now, but eventually, okay, most likely tomorrow, we're going to take them away and try to do it without them there. So it's going to be kind of a process. That's why I created a table to kind of help us out, because I know some of us in here are procedural. Okay, we like steps. We're going to see if we can, if this helps. So we're still going to use the same equation. We're just going to see if we can get this same result by hand. Okay, so the first thing I want us to do is set the inside of the absolute values equal to 0. So for this example, we got 2x plus 4. If we set it equal to 0 and solve for x, what are we going to get? We got negative 2. What was special about that negative 2? Yeah? That's where the lines met. Notice that's how where one ended and the next one began, right? And graphically, that was the vertex. Okay, so by doing this step, you're actually finding where the vertex is located. Okay, the x value, where one line ends and the other one begins. So what we're going to do with this value is create a number line way back when, from like elementary or middle school. And this vertex location, we're simply going to label it on the number line. We're going to test to see what this equation is doing on the left-hand side of that vertex, but also on the right-hand side. So if this is a number line, hopefully we realize the left would go towards negative infinity and the right would go towards positive infinity. So we're going to rewrite this equation in this little interval and this little interval, but when we rewrite it, I want to use parentheses instead of those bars. Okay, you're going to see why in a moment. So if we rewrite the equation, we'll have 2x plus 4 in parentheses and then a minus 3. We're going to write the same thing on the other interval. So the reason that we're using parentheses is because this equation might act differently on this interval than it does on this one. Do you see how graphically the first line goes down, where on the other side it goes up? You see how the lines are acting differently? Okay, we're going to try to determine if this side is going up or down. Okay, which direction is it traveling? And in order to do that, we have to determine what sign, okay, is in front of those parentheses. Is it negative, meaning going down, or positive, meaning going up? So I want us to think about any x value you want between negative infinity and negative 2. Can we pick a number that fits inside that interval? Let's do negative 3. Okay? You could do negative 10. It doesn't matter. We're going to choose this value, and we're going to plug it into just the parenthesis set, because we're testing to see if that's positive or negative. So if you were to do 2 times negative 3 plus 4, would you get a positive number or a negative number? I don't care what the number is. I care if it's positive or negative. Negative, okay? We got negative 6 plus 4. Okay. So what we're going to do is we're going to take that result, okay, that negative sign, and we're going to put it in front of that parenthesis. So it looks like on this interval our graph is going down, because notice how we had that negative answer. Makes sense, right? Isn't the line going down on the left side? All right. Let's try the other interval. So pick a number between negative 2 and infinity. Preferably something easy. 1. Okay, plug it into the parenthesis value. So 2 times 1 plus 4, that is positive. Okay, so we're going to throw in a positive in front of that parenthesis. So now that we know what each piece is doing, okay, on either side of this vertex, we're going to simplify our equation. So take a look at the first one. If we were to distribute the negative in, we'll get negative 2x minus 4 and then the minus 3. Combining like terms, we'll get negative 2x minus 7. We've seen that before, right? Wasn't that the first equation we had at the top? There we go. Okay, let's try the other one. So if we were to distribute a positive sign, nothing would really change. And if we combine like terms, we'll get 2x plus 1. Notice how that was the second one that we found from the graph. So now that our number line is kind of complete, okay, we know what the equations are, we're going to bring it all together to write our piecewise function. So our equations, we had negative 2x minus 7 and 2x plus 1. We're then going to use the number line to help us figure out the constraints, okay, that domain section. So notice how we wrote it here. The first equation showed up in the interval from negative infinity to negative 2. So those would be all x values less than negative 2. Remember, we can include negative 2 because that was a vertex location. There's a closed circle there. The other equation showed up on the interval from negative 2 to infinity. So that would be x is bigger than negative 2. And again, we can count it because that's a vertex spot. So by hand, okay, no graph needed, we can still get the same piecewise function from the absolute value equation. This is what we're going to practice in this section. We'll check it by graphing it, okay, because we have a calculator to do that, but mostly we're going to do it without a calculator. This number line process is something that's referred to as a sign chart because we are concerned about positives and negatives, and we use this a lot in calculus for other reasons. Okay, but this is a good application for us, at least in this course, where it would show up. Okay, let's go ahead and try another one. We're going to step it up a bit. So in this example on the next page, notice how we're adding two absolute values together. Okay, so a little different. This time we have 2 instead of 1. Can we think about, before we actually graph it, and no cheating with a calculator just yet, if you were to graph two absolute values, what do you think it would look like? 2 V's, okay, maybe a W type shape. We'll see. Okay, it's a good estimator. But let's first figure out, can we get that piecewise function breakdown? Okay, what are those individual lines that this graph would have? So we're going to go through the same process, okay, the same thought process, the same steps. So we're going to set the inside of the absolute value equal to 0 and solve for x. This time we have 2 though, so we have to do it twice. Set them equal to 0. And if we solve for x, we'll get negative 4 and 1. What did we say those represented again? Vertex locations. Okay, so we have kind of sharp points on our graph at those spots. Now that we know where the vertices are, we're going to draw our number line and write them in the number line in order. So negative 4 would come first, and then 1 would come second. So since we have 2 vertices, notice how our number line has 3 intervals. You have the left side, the middle, and then the right. So when we rewrite the original equation, we're going to have to rewrite it 3 times. Okay, 1 for each spot. So in our first one, we'll do x plus 4 in parentheses plus x plus 1. And then we'll repeat the process for the other 2. I apologize if you have to write a little small. Maybe you want to write them diagonally, kind of like what I'm doing. Okay. But we're going to use parentheses instead of bars. We want to next determine what the signs are that go in front of those parentheses. So in our first interval here, these should be minus ones, right? My bad. Let's see, in our first interval, can we pick a number between negative infinity and negative 4? Anything you want. Negative 5? Sounds good. Okay, so we're going to plug that negative 5 into the parenthesis pairs, but again, notice how we have 2, so we have to do it twice. Negative 4 plus 5, positive or negative? Negative, all right. What about negative 4 minus 1? Negative, okay? So we need a negative in front of both of those parentheses. Let's go ahead and test our next interval. Yeah?
Why is it negative 4 minus 1?
Oh, sorry, this should be negative 5. That was our test value, I'm sorry. Negative 5 minus 1, that'd still be negative, though. I just wrote the wrong number. Can we pick a number between negative 4 and 1 to test? You think 0 would be pretty easy? Okay, so 0 plus 4, positive, 0 minus 1, negative. Okay. So in front of the first parenthesis, we'll put a plus. In front of the second one, we'll put a minus. Can we pick another number for our third interval between 1 and infinity? 2? All right. 2 plus 4? Positive. 2 minus 1? Positive. So positive, positive. So we have the setup. Okay, just from here we have to simplify, bless you, and solve. So the first interval, if we distribute all the negatives, everything's going to change sign. And combining like terms, we'll get negative 2x minus 3. Okay, so there's one line that we have to graph. The middle interval, if we distribute a plus sign, it's not going to change, but then the negative for the other parenthesis would flip everything. So combining like terms, it looks like the x's would cancel, and we're just left with 5. Okay. So there's another line we have to graph. What would that line look like, by the way, if you just graphed 5? It would be just a point, but if it's a point that shows up on an interval, it's a line. So does the line, is it diagonally, is it vertical, is it horizontal? If you were just to graph 5. What do you think, Seth? It's horizontal. Well, let's try that out down here, okay? So we said that the line of 5 should show up between the x values of negative 4 and 1. So if you go to negative 4, okay, on your graph, you should have a height of 5. If you go to negative 3 on your graph, you should have a height of 5. Negative 2, height of 5, negative 1, height of 5, 0, height of 5, 1, height of 5. So if all those points have a height of 5, it's going to be a straight line across. Let's see if we can find our last one. So all of these were pluses. That means we can just add everything together, and we'll get 2x plus 3. All right, so we got to bring all of this analysis together to write our piecewise function. So the equations, we had 2x minus, or negative 2x minus 3, 5, and then 2x plus 3. And then we'll use the number line to help us with the constraints. So the first equation showed up from negative infinity to negative 4. So those are x values less than negative 4. Again, you can include 4 because that's a vertex. Okay, there's a closed circle there. 5 showed up between negative 4 and 1. Again, you can include them because we have vertices there. And the last equation showed up from 1 to infinity. So x values bigger than 1. So apparently, this graph of two absolute values should be the combination of these three lines graphed together. And we're going to see what that looks like. So down below, we already graphed the middle piece, which is good to go. Let's go ahead and graph the other two. Okay, so the first one and the third one. We already had barriers at -1 and 4. Okay, that's where our vertices were found. That's where one line ends and the other one begins. If we were to graph the first line, we could plug in -4 to get 8 minus 3, which is 5. So we're starting right here, and we can probably use the slope to get some other points, but if we want to show up on the left-hand side, we'd have to use the slope backwards. So we can go up to left 1, up to left 1, and keep going. So there's our first line. We already graphed the line of 5, so then we'll try the last one. Okay, if we plug in 1, 2 plus 3 would be 5, so we're at that second vertex, and if we use the slope, we can find some other points. So apparently that's what our graph looks like if we have two absolute values. It's not exactly two V's together, or a W shape, but it is a merger nonetheless. Okay. Let's check it on our calculator. We'll see how good we were. Alright, so go to y equals, you can clear that out, and we're going to type in the original function. So you got to hit the math button, go over to number, and it's the first one, ABS. And we'll type in x plus 4. We then have to arrow over and add another absolute value. So we'll go back to math, over to number, and get those bars again. And we'll type in x minus 1. Now before we hit graph, let's change our window. We go from -9 to 7, counting by ones. -2 to 14, counting by ones. We'll hit graph and cross our fingers. Looks pretty good, right? I say we did a good job. Now it's nice if you have a graphing calculator because you can always check your work, but notice how we did not use it one bit to help us get here. Okay, this is what we're trying to do in this section. Okay, graph complex absolute value functions without a calculator. And breaking it down into lines is probably the easiest way we can do that. Now just for practice, can we figure out the domain and range of this graph now that we have a picture of it? What do you think, Eli? Sound good? Alright, and then the range, low to high. Yeah? Alright, bracket parentheses, what's going on? Bracket and then parentheses, perfect. Alright, just so we have it in our notes as well, let's write down the buttons that we use on the calculator for the absolute value, because we have a little space here. Okay, so you first hit the math button, and then you scroll over to number. It's abbreviated NUM, and it's the first option, ABS, with a parenthesis. Okay, if you want to check your work using a calculator, you'd have to type those buttons in to graph it. Or you can just trust your gut, okay, and do it by hand. Alright, we're going to stop there for today. We're going to try some more tomorrow. Again, maybe we're going to get rid of the steps, okay, just trying to do it by ourselves, and we'll see how we do with that.